guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Little old me work on amplifiers. I've got my radio DJ talk show voice on just for all of you children. And I was saying, you come from coast to coast and nationwide and all around for all the kids to see, just to watch me work on amplifiers for thee. Gentlemen, I am going to work on a 16 pill for trouble. Yep, let's see, now wait a minute, I got to make sure. Yep, out of them Palm Beaches. Yes, sir. He's my guy. He sent me up this, well, dumpster baby abortion amplifier. It does have Toshibas in it, so we've got that going on. What I think is cute is the 2.5 watt, 100 ohm input resistors, and then over here we've got 2 watt non-flame proof. And this is scary. This is wrong. You cannot add capacitance into the middle of the pile network. Relay woefully inadequate. Got to change that. Power distribution network sucks balls. This is cute. So what we're looking at is about a 60-70% teardown. These sections like here, I think we can all agree are kind of scary. These are held in with countersink drywall screws. Or sheet screws, sheet metal screws, I do believe. It's kind of scary. Basically, I got to climb all over this thing and go over it top to bottom. See, it's like I got to look. See, there's this little 10 ohm here is a little bit different than the one that's next to it. And the transistor's not even sitting in there flat. You can visually see it's torqued over. So I've got a lot of little things I got to tear out. We're going to pull out all the power wires, pull out all these caps. Change the relay. This is not cool. This actually sucks. The great big old mule cock in the sky. And then we got stuff like this going on. We know that cap's no good. No matter even if I slide this thing back over, it's the way the plates are separated in there. It's no good. So we got that going on. We got a little ding in the cabinet over here that we're going to attempt to fix, and this is in the front. And then we go over here and we look at the fans. And the grounds are, wow. So I'm probably thinking we're going to need at least 4 new fans on this sucker. So, with that being said, I'm going to get out my needle nose, wire dikes, screwdriver. I need to reach over here and grab my dental pick of knowledge. I'm most likely going to need this Phillips and make sure my soldering iron is good to go. And we're going to rip this motherfucker apart. So, on that note, away I go. Shall return with more info for you all to follow along with and slobber on later on down the street. So I'll show you guys something. This gentleman says to me, man, BBI, I'm going to make this my last box. Because I don't think, that wasn't even soldered down. He goes, I don't think I'm going to be able to live through another solar cycle. I mean, he's just, he's being honest with me, right? So he tells me, he goes, I want you to make this the best that you can with this particular box. So I'm standing here and I'm looking at it, and I'm just looking at the combiner. I start ripping the combiner apart, not just to change the resistors, but I have to dig off each one of the port wires all these old resistor pieces from when shit's been burned up in the past. So right now I'm sitting here, I'm cleaning up each one of the leads off each port combiner because they're all doped up with piles of freaking leads like this that have come off old resistors. And I asked myself, God, how many times has this thing burned up and nobody's ever bothered to ask why? They just keep replacing transistors. So the goal here is that if I'm going to rebuild this thing for this guy, Let's do them the best due diligence that I can. Now that, see, that's touching this freaking combiner. You guys know that these transformers, they conduct, right? These pieces of ferrite, they conduct. And so if you have these leads touching the ferrites, this port wire here, let's say here, this port wire, if it makes contact with this ferrite, and it also makes contact on this side, you know that's going to cause all kinds of problems, right? You guys know that, right? So just replacing the pill, it's 11:42 at night, and my phone has not stopped going off all day. Just replacing the pill, the problem might not be here. The problem might be here. Or moreover, might be over here. Got to look at all the details. So my mission here, because I have chosen to accept this, is I want to make this as best as I possibly can for this guy. Because honestly, he was being honest with me. He was saying, hey, I think this is going to be my last amplifier that I ever purchase in my lifetime for my mobile. So we're going to make it as best as we can. Now, the back of these transformers, these were hand soldered. These weren't dipped. So it means there's a whole bunch of exposed copper plate. So I'm going to get out a different iron, and then I'm going to flip this thing up, and I'm going to resolder and reflow the back of these transformers so they all look nice and clean. And then we're going to pull the board out, and we're going to unflux this thing. We're going to dip this thing in a tank of acetone and methyl ethyl ketone, and we're going to physically lift all the flux off this board. And we're going to see where we lie after we get that done. This distribution strip that runs down the middle of this thing, you guys can't see it right now. It's been pretty chewed up over the years. And we're going to radically change how the power wires are fed. I don't like going over the input and output network. It's just, it's bad, in my opinion. It's just bad. So we're going to change this relay out. So it means all this gobbledygook back here is going to get changed. I might as well just go ahead and build it my way. So it'll probably be a strain relief that comes out of up here someplace. And then we'll probably put body plugs in these holes over here. Probably do the ground, well, we've got a ground nut over here in the corner. We're going to do a nice brass or copper ground strap over here. We'll probably body plug up this hole here. Woo! And that one here. Woo! So, we're about halfway tore down at the moment. We got some parts out of it. And I couldn't help myself. My towels were getting very, very, very beat down. And I went today with my daughter, and she helped me pick out 5 new towels for the workbench. So, there you go. They're all fluffy and nice and new. Back to the job at hand. I'll return. Flat. I'll beat on that some more. So, took this nylon block and sanded it down so I could sit it in here. And we beat the cabinet out. And now this is flat and square again. This is flat and square again. The gap line here is square again. This face is square. And this edge of the cabinet is square again. So now he doesn't have to spend from now until the end of eternity looking. Oh, don't throw that so far in there, you'll never find it again. Doesn't have to spend between now and eternity looking at a boogered up edge of his cabinet. Because some of this stuff, you guys, really kind of comes down to aesthetics. You know, if a cat's going to send me an amp and say, here, I want you to spend a couple days of your life working on it for me, and this is going to be the last thing I ever own, you can take 10 minutes. This isn't full of Lysol, by the way. This is full of 409. You can take 10 minutes and clean things up, even on a level that, like, no one's ever going to see the inside of this cabinet, like the bottom inside of it. They're not. If they do, I'll be long dead and gone by the time they do. But see, we know we did it. He knows we did it. That's what matters. Clean up all the fins in the back. Give ourselves a nice clean workspace to start over with. See, it's the little details like I don't understand why people would not go through and re-deburr this. I don't get that. It's just shoddy to me. So, you know what? Let's take these garbage Bakelite connectors out of here. Throw those in the FU bucket. Let's go over here and we'll grab nice, beautiful silver-plated Teflon gold inserted connectors. Come over here and we'll grab some of this. A little bit of this love. A little bit of this love. Put some more love in it. A little eyelet. And a little eyelet. Make this the best that you can. Okay. Now the question is, do I want to put metal? I got a really nice plastic plug that'll fit in that. What do I want to do here? I'll figure out something. It's gotta go. It's just bad all the way around. What? Before I even do this, I'm skipping a step. Okay. And lock nuts that have got a washer on them. Imagine that. Star washer on them so they don't back off. It's got solder tabs in it so I can solder the ground directly to the board for the shortest possible distance and bringing electrical conductivity of the board to the PL259 connector to the closest proximity to ground coupling as we can get from each other. Fancy words, simply boiled down, mean work mo better. Okay, let's reinstall our feet. I'll be back. So, another thing to think about as I'm sitting here pulling the last 4 transistors out of the back end of this box is maybe damn it, come here. Maybe the problem has been that there's not enough airflow through this cabinet to get the heat off the transistors. Now, as we all know, 75–80% of the cooling in this particular box is all down to airflow. Okay. Oh, the transistors and they're funky. Legs are all bent up on it. It's all down to airflow. The natural current of airflow through the box will seriously derate transmission time. So you've got to have fairly decent amount of CFM, at least enough to make it so that the air load isn't super saturated by the time it gets to the back of the fins. Oh, let me have it. Thank you. All of this up here looks original for the most part, except for this one transistor. And we're going to go with it's okay. This back here, all this solder work from here back is very scary. And what I mean by that is we're going to zoom down in on just this one here alone, right here. How do I get in there? If you look really close, you'll see that there's a solder bridge between the two leads in the pill strip, and what's the solder bridge is actually this disc capacitor, and it's making connection. Okay, so it's just bad solder work piled on top of bad solder work, piled on top of bad solder work, and you can glob more solder down. But the other thing is like these transistors, I don't think that they were even making contact with the heatsink. I can tell you this one wasn't. I mean, there's freaking solder in the hole. Look at this. Big old hunk of solder down in the hole. These pockets have got to be spotless. So I thought, there's been a lot of damage done here to this area. Let's just go ahead and rip it all the way down. Let's take our time. I mean, I'm supposed to go really fast at this, right? I'm supposed to, oh no, wham bam, thank you ma'am. Let's rip it all the way down. Let's figure out why both sides have had so many failures on the last two or the last four transistors on each side. This transistor is not even in there flat. I can tell just by physically looking at it that it's not sitting in the hole right. And because it was in such poor shape when I first got it, I didn't want to run the chance at $110 per transistor of putting any kind of power to it and running it. Because that could have caused us even more problems. That thing wasn't even sitting, that transistor's dry. Pill pocket's dry too. It's never even making contact with the heatsink. I wasn't initially going to take this one out at all, but that being shorted over, I kind of don't have a choice now. I guess that's why I get paid the 3 pennies per hour to look at this stuff, right? I can see it 20 years from now, I'll be all hunchbacked. I'll be going up to the break. Oh, I used to work on amplifiers back when. Be all hunched up. Nobody will even know my name. Some kid that came out and thought of way cooler shit than I ever could have. It's just the way it works. You know that, right, guys? It's inevitable. Inevitable. It's like inconceivable. All right. Solder's so work hardened. The soldering iron won't even touch it unless I reflux the solder. It's unbelievable. Come here. Let me have it. I am going to have a fat boy 2x6 is going to be remastered. Coming up for sale in the next couple days, by the way, you guys, so keep your eyes out for that. Wow. And I've also got another Henry that I'm going to try and rework sometime before this weekend and get it up and ready to go so it can get the hells out of here. Where did my dental pick go? There it goes. If this dental pick could talk, the literal thousands of transistors this thing has taken out. Whew. So... yeah, I just got to take these 3 out. This really, I think, is a cooling issue. I don't believe there's enough air getting through this cabinet to get the job done. God, none of these are the same lot. 6J, 5K, 5D, 5F, 5K, 7F, 7B, 2E. That's funny. So what are these that I pulled out? It's a 5K. Got a couple of them. 7F. 7F. 6J. 5K, 6J. 5K. And 6J. And I'm looking at this from another angle. This transistor's not even in there flat. God damn, man. Not enough air, or not making good contact with the heatsink. I'm going to keep pulling pills till I feel comfortable to stop. That's all there is to it. I'll be back. I wanted to show you this before I went any further. You cannot keep caking on thermal compound. So there's solder and all kinds of shit. This thermal compound's hard that's in here. Look at this.
Yes, master.
It's so thick that transistor was sitting in there like this and it wasn't even making contact with the heatsink. It's the exact same thing we got going on here. And it's all full of garbage, like, that's a piece of grass. It's like that. That's a piece of grass. It's an old piece of grass that's down inside of here. So, either whoever was changing out their transistors didn't know what the frick they were doing, or they couldn't see the obvious in front of them. This is unbelievable. So, our next step, now that we've got enough of these pulled out to where they're, at least the ones that are in here are flat, is we're going to give it a bath. And we're going to get all this crap out of all the pill pockets, and we're going to get all the flux up, and then we're going to come back and we're going to test these transistors. I don't know. I'm hoping that they're all good. We'll see. I don't know. I don't remember when I talked to the guy last. I can't remember if he told me if this thing was working or not. I'm going with the fact that it was not, since he was seeing problems with it enough to where he didn't feel, you know, trusting enough to run it. So let's give the old girl a douche. Maybe a little salt water, some vinaigrette, spritz, you know. Maybe make it so it doesn't smell like friggin' fish no more, a little bit more like just clean skin. I'm going to say, got down. Well, let's see what we got. I gotta get this segment done. I'm gonna go in the house, go to bed. Really? $28. I'll be damned. Well, that's a good sign. $57. That's a good transistor. $28. I have a feeling those two are going to bump fists for the rest of life. Alright, now to the questionable side. And these transistors will get cleaned, the tabs will get straightened. 15. Not bad, but not great. $14. Those two are matched. It's a good sign. I know the one side's got some problems because the resistor is toast. Junk. Z-nerd. So let's take a quick visual examination of this and make sure nothing is shorted out. $24. $20. $29. Oddball high gain. But at the end of the day, all these transistors are good. So that means we've had a cap go down on us. Interesting. Well, I got to see if I got another transistor that's either a 29 or a 52 to partner up with this. Alright, well, on that note, I'm out of here, guys. I'm going to go in the house. Bump, bump. So, I got my transistors soaking here. I was noticing on this one here that we have a small problem. See if I can get the camera to focus this tight so you can see it. Now this transistor is still good. Problem is, any kind of Synelic glue, any kind of adhesive that I try to glue that lid down with, it has a tendency to migrate its way in and affect the interior of the transistor to the point where it's going to fail. So, fortunately, I'm going to count this transistor as a dud. We're going to set that over here in the screw it pile. I took a bunch of the stuff that was over here, the caps and resistors, and threw them in the trash, but we got to clean all the flux off. Moreover, we got to clean all that acetone, or all the heat sink compound off of them. There's nothing like a little bit semi-aggressive alcohol to get the job done. This allows us to clean the tabs up pretty good. You got to be careful how you treat them, because you can knock the paint right off the top of the pills. So this just gobbed on there. Thermal compound. These transistors have been pretty abused. It's okay, we'll sneak a little bit more life out of them. See, if I was to let these soak like overnight, I'd come out here and the paint would be off the top of the transistors, and it would be like, I don't know if you can remember when X-Force was putting out transistors and they didn't have any labels on them, they were just white dots. People would call foul on that like immediately. Well, those aren't Toshibas, you don't know what those are. Okay. Let's go get rid of the evidence. So if we look real close, I gave this sucker a bath, right? I dipped it in some wonderful chemicals known to cause cancer in everywhere. State of California, even out here in Idaho. We got it all cleaned up, and I'm looking for a certain drill bit here. If we look real close, specifically right here, you'll see that there's a lip. And these all have got lips on the holes where the aluminum is balled up. It's balled up out of the hole, and it's keeping the transistor from sitting flat. And then we come over here and we got the same thing going on. So to make sure that life is good for in the future, we're just going to kiss these. Just kiss them. Just a little bit of love. Not a lot. Just a little bit. Then we'll come through and we'll hit this with a vacuum cleaner. Not an air compressor, because that can drive shit down underneath the board. We'll come along, we'll hit it with a vacuum cleaner. So we'll pull air pressure through it. Just kiss these. Just a kiss. Just like that. Sound like Bob Ross, a dude from Happy Trees. Okay, so we're just gonna come over here today, and we're gonna put some happy trees over here in the corner, and just a little foof and a little foof and a little bit of foof foof, you know. Oh, Bob Ross. He was always on after Sesame Street when I was a little kid. I thought he was the weirdest dude. Well, anyhow, loud noise, here we go. So I'm standing here and I'm checking the capacitance on stuff. 122 puff, that cap is bad. At tells me I'm just going to replace all these output caps. I'm sitting there looking at the coaxes, and my brain tells me that this piece of coax that goes from here to here versus a piece of coax that goes from here all the way over to here, they're not the same length. So then that made me, we'll just use this side as an example. How does a piece of coax that goes from here to here versus here to here? No way those are the same length. Means all that 316's got to come out and I got to redo it. All these cables have to be the same length, that way the RF arrives at each section at the same time. Otherwise we're building imbalance into the box before we even get started. And if you guys remember correctly, this is the one that had the burned up resistor on it. So now that we already know that this has a low capacitance value to it, let's go take a look at this one here. Come on, don't get hooked on the... There we go. Let's go in here and we'll take a quick look for here. So this is really, these caps are too small. I was going to replace them anyhow, but so I pulled all them pills and all the pills are good. Now I'm on the hunt for what's really causing the imbalance. Well, I guess it not being hooked up, that could be a problem as well. Let's grab our little LC meter here. Oh, 125. That could be a big problem. 125, and the capacitor is rated for 150 puff. So we'll go ahead and we'll replace these with metals. Metal clad caps, so we don't have to worry about them breaking down. We're going to strip the coax out, put the coax back in, and now I've got to actually get going on this, so I got to quit video in segments here. Not saying that I'm going to stop, but we come back, all the 316 is going to be down, the transistors are going to be down, and I got my resistor pile pulled, so we'll probably have all the 5 ohmers or 100 ohm or 5 waters either installed or ready to go in. So that's where we're going to cut back at, and then we'll come back and replace the output relay. I went ahead and I pulled up the power distribution bus. We're going to replace this, put a brand new one down, then we're going to drill that. We're going to put 8 power wires in this thing, and then I'm going to run out the back side of the cabinet over here. We'll put 8 power wires out, so we're not going to obstruct airflow underneath. I gotta work. I'll be back. So I just took off these 2 pieces of coax and I wanted to show my point here. That's no good. No good. Clog my solder sucker up every single time. So here's the deal, is that these pill strips are so overloaded with solder that I got to do that with every single pill strip on this side and then this side, and I got to do the same thing over here because they're all just completely tanked full of solder. What started me off on this is that I want to replace all the 10 ohmers so they match, because there's so many different 10 ohm resistors in here. We're lost. So I should have just built you a whole brand new box. Just pulled the pills out and built a whole new box. So I got all the lead sucked out of the pill strips, and man, the hits just keep coming on this box. Grab something relatively flat here. I pick up 2 transistors and I get ready to put thermal compound on them. It's the best way to illustrate this. I think a flashlight will do it justice. I shouldn't be able to see light underneath those. If you notice, we've got one leg bent down and another leg bent up. This one's relatively flattish. So one's kind of sitting flat compared to this one here that is not. I'll tell it to smart lock on that. And I got it very carefully. See, that one's bent too. Ooh, look at this guy. Back in the old days, I just would have sanded these. I would have never even thought it. Man, this thing's all warped. I would just sanded these. I actually got a piece of perfectly delicately flat glass with sandpaper on it, but god damn, that's even worse. The beryllium oxide that's in these transistors, I don't want to end up giving myself lung cancer, so I'm going to see if I can bend these back, and then I got to create some kind of environment to where I can sand these down or make them somewhat flat for them to go back inside the box. Damn. Okay guys, don't try this at home, what I'm about ready to do here. So I got some sandpaper, and I've got it glued down to this piece of heat sink. And I was able to make this work on most of the transistors. Now this is a red dot, okay? So this doesn't have beryllium in it, but we're going to have to sand this down a little bit. I tweaked the other ones around to where I feel comfortable with them, but we've got to make it so the transferable surface area on these is more uniform. There, that's flat. This is also a red dot. Does not have beryllium, but the feeder's so mucked up that I've got to file them. Now, the last one I got to do is a non-red dot. And that's the one we know has got bad juju in it, right? See what I'm saying? Now we're doing this with gloves for a reason. And we're going to do the bad one last. So how this works is it's going to go to a paper towel. It's going to get chemical washed. I change gloves. And all of this I'm going to consider waste. The heat sink, all that stuff I'm going to consider that waste as soon as I'm done here. So here we go. goes to there. This goes to here. We ditch those. This goes to that. And remember, the dust is what we're trying to capture here. So us putting this, the dust is all trapped inside that water, okay? And we don't want to inhale it. That's where we have bad problems. So, transistor's technically clean. Use the paper towel to absorb the water so I don't have to worry about spillage. Take the whole thing and to the trash can it goes. And I've been on this damn box all day. It is 2:30 in the morning this morning, and I finally got it all back around to where I'm peaceful with it, where I can leave it for the night. Okay, so all the transistors are back in, all new 10 ohms, all new 100 ohms throughout the box. Input network's all been redone and rebuilt. All new coax going out to all of the 4 sections on the splitter side. The combiner side's all put back together. Had to move it. It was sitting here. We moved it over here. Permanently mounted down a relay. All new keying circuit. New jumpers going out to the brand new coax connectors. Brand new output induction coil. Redid all of our screws. So the heatsink is actually mounted down now. God, I'm getting tired. I couldn't even see that screw. New screw here. And the coolest thing I was able to find is when I went to go buy body plugs for the amp, I was able to locate a gray body plug for this big ugly nasty hole over here. So we ran the coax down the middle of the the power wire down the middle of the cabinet, tied it off, brought it up, brought it through an actual Heiko connector, so we never have to worry about it splitting like a rubber grommet or anything. Tomorrow I'll go ahead and I'll put a new ground strap in here, solid copper from here to here. We used RG303 coax for the input side, so you never have to worry about it leaking. It's dual shield Teflon coat, high temp wire. 2 brand new LEDs, brand new on-off switch in the front, brand new wire for that. It would have been much easier, and this box would have looked a lot cooler, but it would have been much easier if I would have just stripped this thing completely and put it on a new board. But we're so far along and we're committed at this point. This is where we're going to end up. So tomorrow I got to sit down, I got to figure what kind of remote he wants, which he wants a Foxy style remote. And I can't remember which leg on that they make the return, if they're switching on hot or if they're switching on ground. I think they're switching on ground with that for the remote setup, for the on. I think they're switching on hot. I got to look at that tomorrow. I might have to flip-flop how I got the remote set up. But tomorrow, ground strap, power distribution network. We still don't have the ability to get the 12-volt current out to each one of the very well tested and remounted screws. The other thing that we ran into a problem with is I was going to give you all new mounting hardware on all the transistors. And this is our standard pill screw that we use right here. Okay? And every single one of the pill pockets in that box had a screw like this in it. Had a tapered kind of like sheet metal screw in it. Well, it stripped out all the heat sink. So I had to go and locate you brand new screws, which are 4s, number 4s, and they're 1/2 inch long. And I had to get them pan heads on them. And I replaced all the hardware holding the transistors down because it was all flaky. After seeing all the twisted and bent transistor feet and all of that stuff, I wanted to make sure they actually had a good solid connection to the heatsink to do their job. There was so much going on here with the abortion of repair that had preceded me here. I didn't know which direction to head. You know, I don't know if it's because we're not getting enough airflow through the cabinet. I don't know if it's because of, I mean, some of these, the transistors were in there like, oh, you know, everything's flat. All the legs are down. Everything's screwed down with screws that I actually hold it to the heatsink. Like all of these were stripped. You could just sit there and put a Phillips bit on that thing and just sit there and spin. It wasn't grabbing any metal. There was no pressure being applied. So that's where we're at. Back in the cabinet, and we're on the downhill slope. I'm tired and I'm out of enthusiasm for this project. I've been working on it since 10:30 this morning. Good night, guys. I'll see you tomorrow. Bump, bump. Well, we got our new power distribution network put in. We got all the transistors down, all new 10 ohm resistors installed. We're getting ready to install our new 30 amp relay. Get that sucker soldered in here. And then we'll put in our new keying circuit. We're going to move our tuning tube, and our combiner is too close to our relay, so we're going to scoot it over here. And then we'll probably use like some RG303 or RG400 to bring our input signal over here to our splitter. We'll probably have a stand-up board here with the induction coil here. And then we'll get all of our output network put in, all of our input network put in. And then the last thing I'll do is probably I'll put down my 5 watt 10 or 100 ohm 5 watt resistors. And then we'll do the power wire. And then it should be ready to run. Wire up the small things like the on-off switch, new LEDs, change the remote. But we're finally on the reverse side of things, which makes me excited. We're going to put metal clad caps in here and here, here and here. That way you'd never have to worry about them breaking down ever again, no matter how hot the box gets. And then I've got to, before I go any further though, I couldn't help but notice that we're missing some very important screws. This board has them all. This board has 1, 2, and 3. It's missing 3. So I think before I even solder this relay in, I need to go and mount the board down thoroughly. I was just talking with my wife. This has taken me most of the day to get this far, to get this stripped down, everything tested and put back together. We went in and replaced this capacitor, by the way. Strip down, get put back together, and fight all the solder work. It would have been easier just to pull all the pills out, pull the transformers off the board, and throw this in the trash and start over with a new board and new heatsink. It would have been a lot less time consuming. But we are where we're at now. We're on the turnaround point, so yeah, I'm excited. This is going to work out well. We shall return. Well, let's see. It's started my day at 9 this morning, ended it at 3 o'clock last night, and it is now 3 o'clock in the afternoon, and I'm just now getting headed out here. That's 6 almost straight hours on the phone, sitting talking to people about their projects and things. This is my most favorite portion of the whole project. For some reason, this has developed into my most favorite thing. Now, I've got to put down, normally I don't put down any kind of flux, but because the board here is so corroded already from the previous 4 or 5 builders, I've got to add a little bit of help. Otherwise we're going to get this thing so hot that it's going to burn the copper off the phenolic. So 6 hours of my day so far on the phone. Now we're going to start. I love this part right here. This and doing the power distribution bar. This front edge is going to end up being a little bit sketchy because the phenolic is so chewed up right here. Come on, solder. See what I mean? See why I had to add flux? The phenolic is not wanting to take solder. And it has been this fight for the whole box. Every single thing I've tried to solder, like the pill strips, I spent an innate amount of time on the freaking pill strips. Desoldering them, unfolding the phenolic and bending it back into place underneath all the solder, and getting it to resolder and adhere and not be all bumpy so it'll look good, have good conductivity. That has been the burden of this particular amplifier. But if that little electrical connection can't carry the weak little amps that this thing's going to pull, I'll eat my hat. The downside is that somebody has pre-cut a hole here in the phenolic and there's nothing I can do about it. Otherwise that'd be a perfect looking joint. But that looks good. It's way better than the wee-ass weak connection that was on there before. Well, we're down to the very last little bits and details on this thing. I've got to tie in the output tuning tube. Now I was going to move this, but there's a huge blob of solder that's right here. Huge blob of solder that's underneath this thing. And another huge blob of solder that's here. I spent a half an hour trying to get this off, and then we'd have another big blob, ugly blob of stuff. So we're going to leave this here, and we're going to see how well this works. We'll take a piece of tough uncoated 12 gauge and we'll bring it back to here. We'll see how well that works. So now I get to go spend the next few hours making 2, 4, 6, and 8 power distribution buses to feed each one of the $110 a piece transistors. This thing did not turn out the way I wanted it to. It turned out pretty close, but I should have just stripped this all the way down and replaced the board. That's what I should have done. But it'll look cool. I mean, I lost a little bit in time. Probably 3 or 4 or 5 hours dicking with it because it's so dirty, but the work is clean. So let's get on with it because I need to get this done today.
Oh no, BBI. We know you're not doing fine. You have to clean cum of some young guy off inside of cabinet lid. Oh, BBI, you wipe it down, BBI. Wipe it down, right around the hole. You gotta clean. You gotta get it away from the hole, BBI. Oh yeah. But I hate doing fans. I don't know why. It's part of the process. I understand that. Somebody had spilled pop on this and it was all on the inside of the tin here. Alright. Well, bro, as we covered in the first or second or maybe even the third segment of this video, these are all garbage. We know this because if you get this resistor, if there's enough RF present that the resistor burns up, buddy, you got problems. So, we're going to go ahead and take your, be careful what I show here on camera because this has got your address and contact information and
your bra size on it here. These two, all these grill guards, garbage. We're gonna get you all new ones. All right, so let me do my magic with the fans. Now, the magic with the fans, we'll come back to that. Now, for some reason, they had the craziest thing wired up on the back of this amplifier. They had two 150 amp Anderson clips. They had a ground lead going to one Anderson clip, and then they had this one which was committed dual hot. I don't like doing that. It's dangerous. Somebody's going to hook it up backwards, and it's going to cost you your $110 a piece transistors. The fact that they only had one wire going to one Anderson clip for ground sucks. So what I did is, bro, you might have to put your screwdriver in here and move a couple of the clips around. I wired it so it's safe and it's appropriate. Okay, dual ground, dual hot. This is crimped and soldered. These have now been crimped and they are full of solder. These aren't coming apart, and they're going to give you a good electrical connection. So we're going to be able to cruise a 300 amp load on these two connections. But then you're going to say, but BBI, fully saturated, the amplifier can pull up to 400 amps. Yes, but we don't always run it fully saturated, so we have to peak it over. This will easily be able to handle 400 amps worth of peak draw, especially at 1.5 foot length. So, two separate leads, all tied together with a real strain relief, heat shrink crimped and soldered, heat shrink crimped and soldered. This sucker's done. Done. We'll go do the fans. I'll be back. Those moments that you have as you're going through doing a build project, and you're getting tired of working on the box, you're getting frustrated, which I was with this one. I spent so much time doing even the small little details on this box. It was just rough. I'm not gonna lie, this thing looked not that bad when I first initially looked at this, and I quoted the guy a lot lower number than what I normally should have for the amount of time I spent dumped into this thing. But after you get it running and you have that moment of like a rebirth, because somebody built this thing somewhere out there. They did all this stuff to it. And then I get to come along and I do a little bit of magic to it, and it works so much better. That moment of rebirth just makes you feel, it makes all the energy and effort worth it. I mean, even all the way down to the very end, this thing was fighting me to come back to life. You see these two caps that are right here? See these? This is somebody's idea of a really freaking funny joke. They're input capacitors, and they were right here. These two capacitors are 270 puff. They're spec that they're supposed to be. These were 250 puff. By having different value caps on the input, you're building inherently a misbalance into the box. So first time I keyed it up, I went over in the corner, and I went, whoa. And I went and I looked over here, not like smoke. I mean, they just got warm with the FLIR, and these two sections got hot. And I went, wait a minute. Well, I know my output capacitance right. I know all these parts are matched and right. I know all the turns are right. I know everything's in phase. I know all these caps are good because I checked them all. And I went, well, there's only two other caps I didn't check. And I got down there and I started looking. One's rated at like 244 puff, and the other one is like 251. Still, that 20 puff worth of capacitance difference makes an imbalance into the box. So we got those replaced with two brand new 270 puff capacitors. And this has been almost all the way down to a board off reinstall. There's certain things I would have done differently in here if I would have taken it all the way down to the board, which I think would have saved me a ton of time, but yeah, we're past that point. I gotta let it go. I gotta move on. So where we left off was the fans. So we got 2 brand new JMC fans, or 4 brand new JMC fans in here. And the reason I've got a hot and a ground going is because this cabinet, the way it's wrapped, is going to lend itself to a very poor ground conductor back to the lid. Okay, so I got a ground wire coming up, and it's bonded right here, right there. I'm carrying ground current over to the lid for the fans. It's soldered in right down here. New on-off switch, new LEDs, because the green ones, one was burnt out and the other one, in the process of trying to remove it, the leg broke off. Sorry, man. You get blue. That's all there is to it. So let's go around the lap of the band here and let's start testing this thing. I think that time has finally come in this video. Yay-o-jay-o. What do you guys think? Here's our DC clamp meter. Now, I got on the phone with Foxy today. I love me Christina. She is some badassness. We were talking, she goes, I asked her, I says, what was the biggest amp you ever built, Christina? And she goes, oh, sweetie, I don't know. Let's see, I had a 128 transistor box, and then I had a 264 transistor box. She goes, I think BB and we built one that was 300 and something transistor. And I was like, oh, wow, it's getting up there in Muscle's technology. And she goes, no, Muscle was on another complete page. He was at like, you know, 500 or 600 transistors or something. I was like, God, I'm a man born out of time. I would have given money to been alive in the 80s and the 90s to get to meet some of these people in their prime in the heavy-duty dick swinging days of the CB. It makes me feel very humbled when I'm sitting here just working on my little 2 pills, and my little 4 pills, and my 16s and my 24s. Man, I just hear stories about Muscle, and these legends, I just hear them and I'm like, God, I can't even imagine. I mean, they're, oh, you know, that was back when transistors were $16 a piece, or $12 a piece. My guy, the remote system that he's got set up is switch on hot, but it's got pull plugs in the back, just like this. So this is your hot lead, this is your return lead. So we got a hot lead coming off the bus, through the chokes, going out, comes back, we're switching on hot. So you short these 2 leads together, bloop, amp's going to turn on. Okay? The exact same thing everybody else has got, except they all use a stereo jack. I like to use a mic jack because then it can't come unplugged. Just saying. So I called Foxy and I asked her tonight, because I was on the phone with Prime, and I said, buddy, how did you guys build your remote? He goes, well, we switched them on ground. I said, no, it doesn't seem right to me. So I called Foxy and she goes, well, I switched it on hot. See, now the reason that has to come into the game is because the Foxy Dominator, Skullcracker kind of thing were all, at one point or another, very tightly associated with each other. Now, I'm not going to get into that history. That's not up to me. That's up to some bigger legends in the game that I think are getting ready to launch YouTube channels that are going to blow your guys' minds. Oh, coming soon, Skullcracker near you. I cannot say anything more. But I think 2019 we're going to see some seriously cool shit come out on the internet. At least in the amplifier community for you all to enjoy. He's coming back, boys and girls. That's all I'm going to say. So, she told me switch on hot. That's the way I built your remote, bro. Brand new coax connectors. Basically about 75% new parts inside this thing. And then a whole lot of drama about being able to keep the transistors down to the heatsink. We've overcome all the heating issues in this box, I'm here to tell you, because I've been sitting here twiddly-dinking with this thing for a minute. So where I've got the positive voltage sampled is right here at the remote jack. So I'm going to move this to the outside of the jack. I'm going to take this lead, and we're going to hook it back up here on your brand new, crimped, and hydraulically crimped, not pressure crimped like I seen some other dude do on another YouTube channel the other day. He had himself a little, he'd take the wire and stick it in there, and it was like this one little handle, and he'd go, whoop. And I left him a comment. I'm like, oh, dude, so you don't hydraulically crimp your ends where you put a couple tons worth of force on it uniformly, and you don't solder your ends? He goes, well, did you see me use any solder? You should have watched my video. I was like, well, I did watch your video. It was like, I was shocked that you put like 3 alternators in this dude's truck for a car stereo setup, and you're just going to do, so weak. That's what he did. Anyhow, brand new pressure crimped crimp soldered. So we got two 150 amp Anderson clip connectors. We got both the positive leads going through our amp gauge. We're going to use our 4-pill, our 2-pill, so 2 driving into 4, 50 watt slug in reverse between the 4-pill and the 16-pill. 1000 watt slug, and we're currently in 1X. We're going to work our way up from there. In PEP, 1000 watt slug in average, 5 watt slug in reverse. Back from the brand new Bird 10,000 watt dummy load, which works way better than any other dummy load I've ever had. This box fully chooched out makes 1/10 of 1 watt worth of reflect into the dummy load. 2950, 5 watt slug between the 2950, 2-pill, 4-pill, 16-pill. Everybody got that? Okay, here we go. So now I'm going to demonstrate to you drive power. Hello. There's our 20 whole watts. Our pass-through tune, or otherwise Z reflected, is coming from the RF going from here through the relay and back out and around again. Nothing. 5 watt slug. Oh, wait a minute, I'm over here. 2950. Good. Man, I'm glad I got everything labeled. There's 12 damn bird meters on my bench. I get confused from time to time, you guys. Please, I'm sorry. Nothing. Remember all the different connections that the RF is having to go through. To get down to here. To get to right here. Telling you, we've got a good pass-through tune, so that means you're not going to lose any receive. Okay, so we're going to go ahead, we're going to turn on the 16-pill, and we're going to run just strictly on the 2950, putting 20 watts worth of peak drive into it. Hello, audio. Hello, audio, 1, 2, 1, 2. Our input tune is so flat. She's so flat, 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 back again. That's scooching good. So let's go ahead, we're going to shut down the 16-pill. We're going to bring the 2-pill online. 400 whole peak watts. Now what I'm going to do is I'm going to reach back here, I'm going to take this multiplier, and I'm going to click it up. It's going to make this thing full deflection all the way over here. Read as a 2,000 watt slug. Okay, so you got to do a little bit of math in your head there. Between the 40 and the 60 is 1,000 watts. Goodbye. Okay, so now we're starting to work a little bit. Here is our volt gauge. At 15 volts, and here's our amp gauge. Pulling about 200 amps worth of current. That's just with the 4-pill hitting it. So now, let's shut down the 16-pill. We're going to bring on the 4-pill. Okay, remember how I told you between the 40 and the 60, there's a big hash mark right here, right there. 1,000 watts, right? So we're doing about 1,050. Take this all the way down to the bottom. So now we're going to read this middle scale, you guys. And we're at a couple zeros. So that's 1,000. There's 2, 3, and 4. Okay, so just the driver one more time. Just a hair over 1,000 watts. Now, let's hit it and quit it, boys. There's our 4,000, 3,900-ish. Look at our volts. 14.8 amp draw gauge. About 270 amps worth of draw. Okay. Now, we've got all that fun business out of the way. I want to put some air on this thing. Start cooling off transistors. Then we're going to come over here. We are going to change the 2950 to the D-rail radio. See, I know this because it says derail 29. Plug that in here. So, I know that we're going to see over 1,000 bird, but we're going to graduate there together, you and me. I have no idea what this box is going to do with the big, super hopped up derail radio on it. Okay, we're seeing 850, around 1,000-ish bird with the 2950 hitting it. Ready? Okay. So we're going to come over here. Now, according to one of my friends on Pal Talk, I wouldn't really call him a friend, it's just an associate that I know. He claims because my slugs are so clean and not beat up and not abused and never been dropped that they don't work properly. Because every slug he's ever seen is always beat up. And then he started making fun of me because I have a holder for my slug elements. I was like, or my meter elements. I was like, oh, dude. Okay, so now we got a 5,000 watt slug in average. I'll take 2,500 bird. And about 4,000 peak. On 13.7 volts, pulling 364 amps worth of draw all day long. And I seriously mean that. Like, I'll take that all day. This thing was a rough cookie when it come in here. I mean a rough cookie. It's seen better days. Had been mistreated by other men very, very roughly. She was abused. She was left on a corner like a $5 Tijuana hooker, and somehow found its way out here. I took the beauty marks out of the corner, down here. I did it all without scuffing up the vinyl, by the way. And remember, this cabinet was bent in, back, and up. And as soon as I screw that down, you'll never even be able to tell there was a problem there. She has been restored to full glory. Well, man, I don't think I could do anything more for you on this box. I really don't. Poured 2.5 full days worth of love and joy into this remastering, remodeling of your box. And I truly hope that you go out there and you whoop some serious ass for me down there in Florida. And make sure to mention my name every once in a while. I greatly appreciate it. Gentlemen, without a shadow of a doubt, I am the biggest of the big boys around Idaho. One of the biggest mud ducks that there is out here in the great state of Tater Patch Countryville. I don't know if that counts for anything, but I guess it's a hell of a title to hang on my head. I know I've said it in approximately 600 plus other videos that publicly reviewable today. I appreciate everybody's patience. And as always, I'm so busy it hurts. And I'm grateful for all of the projects and everybody willing to let me just get to things as fast as I can get to them and not rush me too awful much. I thank you guys. I honestly don't get to be here without your all support. And trouble? You keep causing trouble. You got another bullet in your gun, especially from BBI. Put it to good use. Knock some of them boys clean out of the sky for me, would you please? Gentlemen, I gotta get. I'm out of here on this note. Other projects to do, other people to satisfy. I'll see you. Thank you, gentlemen, once again. Bump, bump. If you like what you've seen, click subscribe. I'll see ya. Bye. And guys, I don't know why I've kept saying this, but this amplifier belongs to Troubleshooter, and I keep thinking I'm working on this for trouble. Nope. Troubleshooter out of the sand pile. I appreciate you guys. Seriously. I gotta get. Bump, bump.